All right, let's knock out some homework. So each question is going to have three parts, right? You want to state the common difference, A, and then we're going to have a general formula. So A sub n is going to equal something in terms of n. So whenever you have in terms of n, that means the right side of the equation should have n in it somehow, some way. And C, we're going to use the recursive formula to write a general expression for A sub n in terms of A sub n minus 1. So A sub n minus 1, we know, is a previous term. So we want to define A sub n, right, some term in terms of a previous term, which we'll see that here in a second. And I guess for B, going back to B, right, A sub n in terms of n being that place in line, right, that index, that spot in line. So let's just see. All right, so if we look at 21, the sequence is 1, 1, 2, 3, 5, 8. Which, if you don't, I mean, this is a very specific sequence. The question is though, is it arithmetic? Is there a common difference? Right? Is there a common difference from one term to the next? Well, from 1 to 1, there's no, not at all. So this is not arithmetic. So I don't got to do any of the things, right? Because this is not it. We're only concerned with arithmetic sequences. This one is actually the Fibonacci sequence, which we'll talk about in a later video probably. So 21, can't do anything with it. Can't do it. 22, on the other hand, 20, 17, 14, 11, and 8. Is this arithmetic? So let's see. From one term to the next, we're subtracting 3. 17 to 14, we're subtracting 3. Subtracting 3. Hey, look, we're subtracting 3. So the common difference, little d, the common difference is -3. So yes, this is arithmetic, and the common difference is -3, which we use the letter little d to denote that. All right, so A is good, right? Because state the common difference. Boom, there it is. Common difference. All right, now we want to write a formula. So A sub n, right? Any term in this list, we want to be able to plug in a number n. So for instance, if I want the first term, I want to be able to plug in n equals 1 and then somehow spit out 20. So if you recall from the notes or the last video, it's A sub 1 plus n, right? In terms of n, like that's our variable, minus 1 times d, which is the common difference. So A sub n is equal to A sub 1, which is the first term, 20, plus n, that's the variable, minus 1 times -3, the common difference. So there it is in terms of n. Now, if we wanted, could we simplify? Sure, I guess we could. This would be, what would this be? Actually, I'm cool with this. Right, I'm cool with this. This did exactly what we were asked to do, right? In terms of n. Now, if you want to see what it would look like, I guess simplified, 20 plus, we would distribute -3n plus 3 which would be 23 plus, not plus, minus 3n. So 23 minus 3n. A sub n, so for instance, like test it out, right? Test it out. A sub 1, right? N is equal to 1. So a sub 1, the first term should be 20. Well, let's see. 23 minus 3 times n is 1. So that would be 23 minus 3, which is in fact 20. And then if you did this for n equals 2, right? A sub 2, the second term in the sequence, which is 17. When you plug in n equals 2 into the formula, you should get 17, right? 2 times 3 is 6. So 23 minus 6 is 17. And you could keep this going. You could figure out any index, any term based on this formula. All right, so that was part B, right, in terms of n. So now, if we use the recursive formula and write a general expression for a sub n, so for any term, but in terms of the previous term, right, n minus 1. So this would be 20 minus so let's think about this for a second. Oh, okay. So this would just be a sub n minus 1 minus 3, right? You take whatever term that you want. Well, you take the previous term and you subtract 3. Is that true? So let's see. Obviously, we can't start with 20, but if we started with 17, right? If we started with 17, we would take, so a sub 2, that would mean a sub 1 minus 3, right? A sub n, in this case, is a sub 2, right? So this is in general for this problem, and then this would be specifically for this problem. So a sub 2 would definitely, the second term, 17, is 100% the first term minus 3, 20 minus 3. And then you could keep it going, right? A sub 3 would be a sub 2 minus 3. It would just keep it going, right? Like it's recursive. It over and over and over and over and over. All right. It takes some practice, man. Like once you start seeing more and more problems, it gets very, very repetitive. So here, from 3 to 7, we're adding 4. From 7 to 11, we're adding 4. So now, based on just this information, I would safe to say that if this were the same pattern were to keep going, then it's definitely arithmetic. And the common difference, so little d, is going to be plus 4, positive 4. All right, so using our formula, all right, a sub n is going to be equal to the first term, 3, plus n minus 1 times the common difference of 4. So there it is. But if we want to simplify it, 3 plus distribute 4n minus 4, which would be 4n minus 1. So any n term, whatever term you want, the first, the second, third, 10th, 100th, you just let n equal whatever term you want, and you run it through the formula, and it'll tell you what that term is. Using the recursive formula, we know that a sub n is going to be the previous term plus 4. Right? Any term you want will be the previous number plus 4. That's what I'm getting out of this. So all right, a sequence is defined by a sub 1 being 13. So the first number in the sequence is 13. And any number, any term, can be found by taking 5 and adding it to the previous term. So this is what we would call the recursive formula, right? So for instance, it would be 13. So then a sub 2, right, the next term, would be 13 plus 5. Right, this is a sub 1. This would be a sub 2. Do a couple more. Well, we got to do the first 5. So then a sub 3 would be 18 plus 5, so 23. A sub 4 would be 28. And then a sub 5 would be 33. All right, so these are the first 5 terms in the sequence that's defined by this criteria, right? A sub 1 being 13, and then a sub n being 5 plus the previous term, a sub n minus 1. All right, let's make sense of problems. Let's find the first term. So let's see. What is happening? How are we changing from one problem to the next? So if we rewrite it so it all has the same denominator, this would really be 6 over 8. And this would be 4 over 8. Okay, so what's happening? We are, as n goes up by 1, right? N goes up by 1. A sub n is going up by, actually it's going down by an eighth, right? So here we're adding 1, we're adding 1, we're minusing 1/8. We're adding 1, we're subtracting an eighth. So this says to find the first term. So what would n equals 1 be? Well, 2 would be 8 over 8. And 1 would be 9 over 8. And that makes sense because it would be decreasing by an eighth every time. So the first term would be 9/8. Determine whether or not each sequence is arithmetic. If the sequence is arithmetic, state the common difference. So plus 4, no, I took that back. Plus 1, right? 4 plus 1 is 5. Plus 2, we can stop right there. Not. Right? It doesn't matter if they're all plus 1 and one of them is different. That doesn't matter. They all have the common difference has to be the same everywhere. So B, plus 2, plus 2, plus 2. Hey, yes. Yes, it is. And the common difference is 2. All right. What is this? Minus 3, minus 3, minus 3. Too easy. Yes. And the common difference is minus 3. Is that all we have to answer? State the common difference. All right. If it is, state the common difference. All right. Determine whether or not each sequence is arithmetic. So again, this is yes or no. If the sequence is arithmetic, use the explicit formula to write a general expression for a sub n in terms of n. So a sub n is going to equal some kind of formula with n in it. So if we recall, a sub n is equal to the first term plus n minus 1 times the common difference. Okay, if it is in fact arithmetic, then this is what we're going to use. So let's see. From 4 to 12, we're adding 8. 12 to 20, we're adding 8. 20 to 28, we're adding 8. So yes, this is common difference is going to be 8. Well, we need to write it in an expression. So a sub n is going to be equal to a sub 1, which is the first term, plus n minus 1 times the common difference of 8. So simplifying this, we're going to get 4 plus 8n minus 8. Combining like terms, we're going to get 8n minus 4. So a sub n is equal to 8n minus 4. Okay, we add 5, we add 10, not, right? Common difference is different, not arithmetic. Okay, this is going to be minus 4, minus 4, minus 4. So yes, it is. Common difference is negative 4. So the formula for a sub n in terms of n is going to be the first term plus n minus 1 times the common difference of negative 4. All right, simplifying this, we're going to get 4 plus, actually it's going to be 4 minus 4n plus 4, which is 8 minus 4n. So a sub n, in terms of n, 8 minus 4n. It's kind of fun, right? I feel like we're doing stuff. Okay. Determine whether or not each sequence is arithmetic. So same thing. If the sequence is arithmetic, use a recursive formula to write a general expression for a sub n in terms of the previous term. So a sub n minus 1, right? This means previous term. All right, so let's look and see. Is this or is this not? So we're adding 0.5. We're adding 0.5. I feel like this is it. So yes, it is definitely arithmetic. All right, so a sub n is going to be a sub n minus 1, right? The previous term, whatever the previous term is, plus 0.5. And a sub 1 will start at 7, because you kind of have to know where to start, right? Okay. All right. This is plus 1, plus 1, plus 1. All right, so yes, this is. Common difference is 1. So a sub n, well, if we let a sub 1 equal 6, then a sub n is going to be a sub n minus 1 plus 1, right? Whatever the previous term is, plus 1. So let's think about that for just a moment, right? If I know that a sub 1 is equal to 6, a sub 2 would be a sub 2 minus 1 plus 1. So a sub 2 minus 1 is really, what's 2 minus 1? A sub 1 plus 1. So a sub 2, the second term in the sequence, should be the first term plus 1. And in this case, the first term would be 6. 6 plus 1 is 7. So a sub 2, the second term in the sequence, should be 7. Oh, and hey, look, it is. So in terms of the previous term, this is what they're talking about. Okay, so here's kind of an interesting one. It's so from -2 to 4, we're adding 6. But then from 4 to -8, we're actually subtracting 12. So no, we'll see these sequences later. It alternates. All right, so no, this one is not arithmetic because the common difference is different. All right, find the indicated term of each arithmetic sequence. Okay, so here we're looking for a sub 15. So this is n equals 15. We're looking for the 15th term in a sequence of numbers that starts at 4 and goes up by 5, right? Common difference of 5, right? This a sub 1 is the first term, d is the difference. So 9, 4 plus 9, 5 is 9, plus 5 is 14, plus 5 is 19, ... Right? If this were to keep going, I couldn't keep this going and write out 15 different numbers, but there is a better way. So a sub n, in this case 15, is equal to the first term, 4, plus n, which is 15, minus 1, times the common difference, which is 5. So simplifying, 4 plus 14 times 5. What's 14 times 5? 4 times 5 is 20. Carry the 2. 5, 6, 7. So a sub 15, the 15th number in line or in order would be 74. So if you started this list ... the 15th term would be 74. Okay. B. So we're adding 4, 8, 9, 10, 11, 12. All right, so 4 plus 4. So common difference is 4. We want the 20th term, so n is equal to 20. So a sub n is going to be equal to the first term plus n minus 1. So 20 minus 1 times the common difference of 4. So 14 is, or a sub 20 is going to be equal to 14 plus 19 times 4. So 2, 4, 6, 8. 80 minus 4, 76. 14 plus 76, which is 80, 90. So a sub 20, the 20th term in this list would be 90. It's kind of interesting. I'm not going to lie. This is fascinating for sure. Minus 4, minus 4, minus 4. So common difference is -4, and it's arithmetic. And we want n equals 18, right? We want the 18th term. A sub 18. So A sub 18, it's equal to the first term plus N 18 minus 1 times negative 4. So 45 plus 17 times negative 4. Or 17 times 4. 17 times 2 is 34. 34 times 2 would be 68. So 45 minus 68. This would be 23? Negative 23? Is that true? $68 minus 45 would be 23. So it would be negative 23, right? Negative 23. All right, no calculator. Find the sequence for which A sub 8 does not equal 24. All right, this is so we're adding 3, we're adding 3. So A sub 8 is equal to 3 plus 8 minus 1 times the common difference of 3, which is 3 plus 7 times 3, which is 3 plus 21, which is 24. So does not equal 24. So A does equal 24. So not A. So negative 32 to negative 24. So we're adding how much? 6, 8. So we're adding 8. We're adding 8. So A sub 8 is equal to negative 32 plus 8 minus 1 times 8. So this is going to be negative 32 plus 7 times 8, which is 56. And that's going to be 24. So B equals 24 also. All right, 108 to 96. We're subtracting 8, 9, 10, 11, 12. We're subtracting 12. Subtracting 12 again, 96 to 84. Okay, so A sub 8 is going to be 108 plus 8 minus 1 times negative 12. Okay, 108. So 8 minus 1 is 7. 7 times 12. 12, 24, 36, 48, 60, 72, 84. So minus 84, which is 24. Okay, so C, it also works. All right, we're adding 4. We're adding 4. So A sub 8 is going to be A sub 1, which is negative 8, plus 8 minus 1 times 4, right, times the common difference. So this is going to be negative 8 plus 7 times 20 times 4. 7 times 4 is 28. 28 minus 8 would be 20. So D. D is, of the 4 A, B, C, D, does not, A sub 8 does not equal 24 for D. Okay, word problems. Let's see. All right. A radio station offers $100 prize on the first day of a contest. Each day that the prize money is not awarded, $50 is added to the prize amount. So for instance, on day 1, it's $100. On day 2, it's $150. Day 3, 200, 250, 300, and so on and so forth. Okay. If a contestant wins on day 17 of the contest, how much money will be awarded? Okay, well, we know that we're adding 50. So that's the common difference is 50. The first term, so, well, we're looking for the 17th day. So n is equal to 17. So a sub 17 is equal to the initial amount, or first term, a sub 1, plus 17 minus 1 times the common difference of 50. Okay, 17 minus 1 is 16. So 16 times 50. So this would be 30. 8. So on day 17, it's going to be 100 plus 800, which is 900. So $900 is what the contestant would win in a contest that does this on the 17th day. Okay. If a sub 4 is 20 and a sub 12 is 68, find a sub 1, a sub 2, a sub 3. All right. So what do we know? We know that a sub 4 is going to be equal to a sub 1 plus n minus 1 times the common. Okay, hold on. Look. So n we know is 4. Right? N we know is 4. Minus 1 times the common difference. But we don't quite know what a sub 1 is. That's okay. Because what can we do here? A sub 1 plus 4 minus 1 is 3 times the common difference. Okay, a sub 4 we know is 20. All right, that's all we can do. Right, I just plugged in the things that I know. Right, a sub 1 was 20. Or no, not a sub 1. I'm sorry. A sub 4. Right, a sub 4 was 20. And it's equal to, sticking to the formula, a sub 1 plus n minus 1, which would be 4 minus 1, which is 3, times the common difference. All right. A sub 12, on the other hand, would also be a sub 1 plus what? 12 minus 1, right? Because n is 12 in this case. In the first case, n was equal to 4. Second case, n is equal to 12 times d. So this is going to be 68 is equal to a sub 1 plus 11 times d. Okay, this is where we got to reach back, way back. We have two formulas that have two variables. So 20 is equal to a sub 1 plus 3d. 68 is equal to a sub 1 plus 11d. So what I want to do is I want to subtract these. Why do I want to subtract these? Because then the a sub 1s will cancel. So this is a way of doing it. So essentially what's happening right now is that we have a system of equations, right? We have a system. If you think back to when we did like matrices and linear linear equations, a system of linear equations. So there's a couple different ways. I could substitute, or I could just subtract these. I like subtracting. So 20 minus 68 would be negative 48. A sub 1 minus a sub 1. That's nice. That just goes away. 3 minus 11 would be negative, what was that, 7? No, 8, 9, 10, 11. 8D. Now, did I have to write them this way? No, I could have wrote them the other way. So when I subtracted, I don't get the negatives. That's one way of doing it. But really, it doesn't matter because I'm about to figure out what D is right now. D is equal to 6. So we just found that if a sub 4 is 20 and a sub 12 is 68, they're going to be terms in a sequence that has a difference of 6 from one term to the next. So with that being said, if we plug that 6 into the original formulas, we can figure out what a sub 1 is, I feel. And into either one, it truly doesn't matter which one. So I'm using one with smaller numbers. So this would be 6. So 20 is equal to a sub 1 plus 3 times 6 is 18. So minus 18, minus 18. A sub 1 is going to be 2. Then a sub 2, I don't need to do any more formula because I know the common difference is 6. So 2 plus 6 would be 8. A sub 3, 8 plus 6 would be 14. So a sub 1, a sub 2, a sub 3 are found. Dang. Linear equations came out of nowhere, or a system of linear equations came out of nowhere. Good thing we already learned that. So, number 8. Find the indicated term in the arithmetic sequence. Okay, so more of this. So, n is equal to 12. So this is going to be, what is this going to be? We want the 12th number. So a sub 12, it's equal to a sub 1, negative 2, plus 12 minus 1 times common difference of 4. So negative 2 plus 11 times 4. So negative 2 plus 44 is going to be 42. So a sub 12 is equal to 42. Let's go. Okay. So 15, 19, 23, 27. We want a sub 10. So n is equal to 10. That's what we want. The common difference is going to be, it looks like 4. It is. So the common difference is positive 4. So a sub 10 is equal to the first term, which is 15, plus, in this case, since n is 10, 10 minus 1 times the common difference of 4. So 15 plus 9 times 4, 15 plus 36, 46, 51. So a sub 10 is going to be 51. I feel like we're really cooking here. So minus 6, minus 6, minus 6. Common difference is going to be negative 6. And then a sub 20, so n is equal to 20. All right, a sub 20 is equal to the first term, 46, plus 20 minus 1 times negative 6. So 46 is equal to 19 times negative 6. So 9 times 6 is 54. Carry the 5. 6 plus 5 is 11. So 114. 46 minus 114 is going to be negative 54 plus 14, 68. Negative 68. All right. A sub 20 would be negative 68. Ooh, we're almost done. Let's go. So what is the first value of n that corresponds to a positive value? The first value of n that corresponds to a positive value. Explain how you found your answer. Oh, man. All right. So what am I thinking? What's the difference? We're adding. So 2.5. 2.2. No, yeah, 2.2. 2.5 and 2.2. 2.5 and 2.2. 4.7. We're adding 4.7. Is that true? 5 take away 7, 0.8. Yeah. And then from here to here is also plus 4.7. So 4.7 is the difference. That's the difference. We want to do this so that we're looking for an a sub n. So the first positive one, so bigger than 0. Explain how you found your answer. So I wonder how many 4.7s are in 42.5. That's how many times we're gonna have to. That's how many times we're gonna have to add it, and it would be. So let's think about that, right? Because I know that I'm starting at 42.5 negative, and I'm adding to it 4.7, and then another 4.7, and then another 4.7. So I want to see how many 4.7s do I really have to go. So let's see, 6. 6 times 7 is 42. 6 times 4, 24, 5, 6, 7, 28. Oh, it's got to be way more than that. So it's probably going to be like 9. 9 times 7 is 63. 9 times 4 is 36. 36 plus 6. 36 plus 6. 42. Let's go. So 0.2. So what that means is that if I start at 42.5 and I add 4.7 9 times, then it won't be quite 0. It would be actually negative 0.2, right? Because there's a 0.2 over a remainder. So that means I would need to add one more 4.7. So n equals 10 will definitely correspond to the first instance of a positive value for a sub n. It would be positive 4.5, I believe, right? Because 0.2 plus 4.7 would be 0.5, 4.5. So you can just write down what I said. That's how I explained it. I had to divide. It's kind of crazy. All right. Find the first 4 terms in the sequence with using this. Okay. If a sub 1 is 2/3, then any value on any term is going to be the previous value plus 1/6. So what this is saying is a sub 2 is going to be a sub 1 plus a 6. Well, a sub 1 is really 2/3, and I'm adding to it 1/6. So this is going to be 2/3 is really 4/6. 4 plus 5, or 4 plus 1 is 5/6. Okay. A sub 3 is going to be the previous term, so 5/6 plus 1/6, which is going to be 6/6, which is 1 basically. A sub 4 is going to be the previous value plus a 6th. So it's going to be 7/6. So find the first 4 terms of the sequence. There it is. 2/3, 5/6, 1, 7/6. Those are the first 4 terms. All right. Is this the last one? Yeah, it is. Let's go. So if a sub 1 is equal to 3.1 and a sub 5 is equal to negative 33.7, okay, write an expression for the sequence to find a sub 2, a sub 3, a sub 4. Okay, so this is another linear system of linear equation problem, I feel. Because, right, what do I know? I know that a sub n is equal to a sub 1 plus n minus 1 times d, right? I know that. That's the formula we've been using. So when n is 1, right, n equals 1, a sub 1 is going to be a sub 1. Oh, I take that back. Oh, yeah, sure. A sub 1 is going to be a sub 1 plus n is 1, 1 minus 1 times d. Something doesn't seem right. So a sub 1 is 3.1, which is equal to 3.1 plus 0d. Okay, that didn't work out. That didn't work out the way I thought it was going to at all. So let's see. N equals 5. That means a sub 5 is going to be equal to a sub 1 plus 5 minus 1 times d, which is a sub 5 is equal to a sub 1 plus 4d. In this case, a sub 5 is negative 337. A sub 1 is going to be, or negative 3.7 is equal to a sub 1 plus 4d. Okay, well, I got one equation. What's up with the other equation? N is 1. A sub 1. Okay, you know what? Let's just roll with it. Let's just roll with it. Let's figure out what d is. So, oh, haha. We don't even need a system of equations because you probably already saw it, right? A sub 1 is 3.1. And look, I have an a sub 1 right there. So actually, we can say negative 3.7 is equal to 3.1 plus 4d, which is the common difference. Okay, the method I was doing with the system of equations, kind of like in the last problem, you needed something other than a sub 1. Like, had they given us like a sub 2 or something other than 1, then this would have worked out. But it's all right. We're getting it now. So this is going to be minus 3.1 minus 3.1. So it's going to be even more negativer, even more negative. So this is going to be negative 36.8 is equal to 4d. Divide both sides by 4. All right. And without a calculator, the common difference is going to be 36 divided by 4, which is 9, negative. And then 0.8 divided by 4 would be 2. So negative 9.2. That's the common difference. That doesn't answer the question. Or that's not what we're looking for. We're looking for A2, A3, and A4. So if the common difference is negative 9.2, then that means that A sub 2 is going to be equal to A sub 1, which is 3.1, plus 2 minus 1 times negative 9.2. So this is going to be 3.1. 2 minus 1 is 1. That's nice. Minus 9.2. So this is going to be, so A sub 2 is really going to be negative 6.1. In fact, we probably don't even need to do that because I know what the common difference is. We can just say 3.1 minus 9.2. Oh, that's 6.1. Then A sub 3 is going to be negative 6.1 minus 9.2. So that's going to be negative 15.3. Right, once you find that common difference, that's, I mean, it's downhill from there for sure. So negative 15.3 minus 9.2. Now, as long as the difference truly is 9.2, right? I don't have a key or anything. I'm going off of faith in my own mathematical skill here. This is going to be negative 24.5. Right, because you're just adding it and making it more negative. So there are the first A2, A3, and A sub 4. All right. Good luck.